Cyrus, you're up for it.
All right, Ssendi, thank you so much for this opportunity. Good evening, everyone. Just for a recap for yesterday's class, we looked at cloud computing advantages, which we termed as well as characteristics. And to mention a few, we looked at on-demand self-service, broad network access, rapid elasticity, resource pooling, among others. We went to the term, why the term cloud computing, and from then we went to the origin and development of cloud computing, where we went through a number of years from 1969 to 2004. And then we went to the brief history of computing, where we began with parallel computing, grid computing, distributed computing, and cloud computing. And then we went to the cloud deployment models, where we looked at public cloud, private cloud, hybrid. I think that's where we stopped. We stopped on the cloud deployment models, which marked the end of our class yesterday. Thank you so much. I get back to you, Ssendi.
All right. Thank you, Cyrus, for that introduction. Well said. Today we are looking at the introduction to compute virtualization. We are looking at the introduction to compute virtualization, and in today's chapter, we want to understand and we want to look at what is compute, what do we mean with when we say compute, and also what is virtualization. Why do we even need to virtualize anyway? So this particular section basically focuses on infrastructure as a service, because cloud computing is built on the virtualization architecture. Okay, so we are saying that cloud computing 1.0, remember the versions we talked about in the previous chapter. We said we have 1.0. Who can tell me the other two?
2.0 and 3.0.
Okay, so but we are saying this particular chapter focuses on cloud computing 1.0, which we said focuses on virtualization, which has today become the foundation of cloud computing. Okay, this chapter focuses on the architecture and technologies involved in compute virtualization. So upon completion, or what we want to achieve today, we want to be able to describe what virtualization is. We also want to be able to understand differences between virtualization and cloud computing. And also we want to understand KVM technology. Gaba Nicholas, could you please mute your microphone? And also understand Huawei's Fusion virtualization solution. This is the solution for Huawei, and it is called Huawei's Fusion Sphere. And we are going to be looking at it in the coming few chapters. So we are going to look at the introduction of introduction to virtualization. So the question is, what is a virtual machine? Who of you here has heard of a virtual machine? So we are seeing here that a virtual machine is more like a container, if you can think, that is going to get all our underlying hardware, and it is going to be using it, and it's going to be independent of that hardware. So we are seeing that virtualization is the foundation, and before we have a virtual machine, we must have some kind of virtualization somewhere, somehow. And we use the virtualization technology to create or come up with virtual machines. So in brief, a virtual machine, like you hear the word virtual, is like a physical machine, but it is virtual, running or simulating to use the existing hardware as it is the hardware that is below it. So in other words, it emulates those hardwares and it uses them to achieve or to be able to do the compute functions that you may require from any given computer. So if you go here ahead and see that this guy is asking what is a virtual machine. On my computer here, I have my software which I installed to be able to access or to be able to run Linux. I didn't really want to install, because for you to be able to install Linux, that means you have to install either dual boot, and you have to first boot out of your operating system for you to be able to go into another operating system. And let's say you are let's say a pen tester, and you are a specialist in security, and you want to test, or you want to hack, or maybe you want to try out a few things, but you don't want to first log out of your Windows machine. As you can see, I'm using this virtual machine inside my Windows machine. And also you can take note that I have another virtual machine here called the Ubuntu 64-bit, and I also have the Kali Linux, and I also have the Windows 10 64-bit operating system installed in my virtual box, and those are my different virtual machines. And even if I wanted to create more other operating systems, it doesn't necessarily need me to first shut down this class, simply because you see my Kali Linux has started. So I don't have to first shut down my class and close Zoom and shut down and then make a bootable flash and then start installing and configure operating system. All I need to go is go to my workstation, the VMware workstation, and then I say create a new virtual machine, and then it will ask me details. You can select advanced if you want to use some of these controller types or virtual disks, or you can just go with a typical one if you want to use it in a typical or in the most common way. So here you go ahead and you select the operating system which you want your virtual machine to have. And you see, I am running it alongside my operating system. Maybe let me first cancel this so that I minimize this so that you're able to see. And I also first, so that you're able to see that I'm running this inside my virtual. So this is my Kali Linux, and I wanted to create a new one, okay? This is my virtual box, and I can even choose to power both of them and they run at the same time, okay? I want to power both of them and they run at the same time. So I can also go ahead and start this virtual machine, and you see it is also starting, and I also have my Linux starting, and I can choose to log into my Linux with my details, and then I can be able to do what I need to do. And then if I wanted to create another virtual machine, maybe I would just come here and go to my workstation and say create, and then select the types I want, then select the installer disk, or if you have a bootable file that you can use to install your operating system, or you navigate to where your operating system is. If you want to, let's say, install Windows or the NetWare or Linux, depending on what you want, or even if you feel and you feel like you want to, let's say, like install maybe the recent Windows for you, and then you go ahead and you select your bootable operating system, then it will detect for you. You go ahead and select next, you give it a name. This is Windows 10, the June update. And then you go ahead and select where you want to store your virtual machine. And in this case, I'm going to store it on server X, and then you select where you want to store it. And maybe after this class, you can even go ahead and choose to, you can go ahead and configure and install some VirtualBox by yourself so that you can play along, you can play with those different functions so that you can get a feel of how it feels like to run a virtual machine inside your operating system. So you can see these are the basic configurations, and if you want, you can even go ahead and you configure or you customize your hardware resources. And like I said, with virtualization, we are just emulating, and I can choose like, you know what, let me give this like 3 GBs, let me give this like 4 GBs, let me give this like maybe 10 GBs, and maybe I give it one processor, or should I attach a media or storage to it? What kind of network interface card do I want it to have? Should it be host only? And so on and so forth. And when you're happy with your settings, you just go and say finish. And I am done creating the virtual machine. And the next time I'm going to power it up, it is creating the disk. And if you come here in my server X, you will see that these files have been created inside my virtual machine folder, and I have my Windows folder there, and these are my files for Windows 10 update. I don't know what is inside there, but you see the files are there, VM 8DK. You'll see that file extension in a short while. But it is creating the hard disk. It takes longer if the hard disk is big, because my disk is huge. So it takes longer, and I selected that option. I should have selected the first option of creating a single file, but which is okay. And now, so that is how you create it. And in a short while, when it is done, I'm going to come back and we power it on, and it will start install Windows. And then we shall get back to it later when the Windows installation is done. So what am I trying to say? I'm trying to say that a virtual machine is a machine that is emulating the existing hardware resources that are available, and we can have as many as you see here to help us do that different kind of things you want. So it is helping us, in other words, utilize the hardware resources that are available. So here we want to go ahead and look at virtualization. We want to go ahead and look at virtualization, and we are asking ourselves, what is virtualization? I've also talked about virtualization, and maybe I will talk about it again. So with virtualization here, we are seeing that we have our physical server, right? We have our physical server, which is this one. And we all know that our physical servers, they have resources like the CPUs, they have resources like the memory, they have resources like the hard disk, and they have resources like the network adapters, or let me just say the network interface cards. So when it comes to virtualization, what happens is that you get this server here, and is that you get that server there, and you put it like in one given folder. You put it like in one given folder, which we are calling a logical file. So it gets all those resources that I've mentioned, and it puts it into one folder like a logical file. And inside that logical file, we have configuration files, and we also have the user data files, where users store their data, or you have the configuration file and the user data files, which contain the data that is being stored on our physical server. So we are saying the instance of virtualization, it is basically to separate software from hardware, because we have, as you have seen, we have converted the physical devices into these logical folder or files, so that our hardware resources now, we can get this one computer now, and we divide it according to the needs that we have. And as you can see, it turns out that we have one computer here, you see, and this computer, we already said it has the configuration files and the user data files stored on it, okay? So we go ahead and we can now create more computers, or what we are calling now virtual machines, from this one physical server. Well, you remember the limitation to our normal traditional physical server is that you can only run one operating system at the same time. You cannot run, let's say, Windows, and you cannot run Linux on your computer at the same time. Even if you install and you have dual boot on your computer, you have to first sign out and log out of one, and then you're able to log into the other so that you can use them. But you cannot use them at the same time, and unless when you decide to virtualize, which we are now trying to understand. So here we virtualize, and you see we have created more virtual machines, and this could have its own operating system. This as well could have its own operating system with its own memory and its own CPUs allocated to it and other resources, even this one and even this one. And you can run as many instances on those different virtual machines. Like as you see here in the virtual machine that I was trying to create here, as you see in the virtual machine that I was trying to create, I think this is the one. Let me, the June update. And I want to go ahead and I enter the setup. I need to configure, boot options. I need to configure where it's going to boot from and select the boot media. I'm going to do this during my break so that I boot from my bootable drive that I've created so that I'm able to launch our Windows 10 June update and release, sorry. Okay, so as you see now, we are already booting. Like it did not take us a lot of time for us to be able to boot. Let me clear these things on our screen. We did not take a lot of time for us to be able to create a virtual machine, another virtual machine inside our operating system. So we have all these virtual machines and they're already running, and we see we're already good to go. Just we don't have to either buy another computer and we are able to, for us to create the test environment or for us to be able to run the other applications that we want to run on our servers. And that is how you create a virtual machine that we talked about in the last slides. So in virtualization, that's what it does, and it gets these other virtual machines and they are all at the same time running inside our one physical server, which we said, yes, please.
Someone.
Yes, please.
Before you create a virtual machine, don't you have to first consider the specifications of your machine, your actual machine, like its processor speed and so on, even the storage? Don't you have to first consider it, or you can do it on any machine?
Of course, also you need to put that into consideration, but depending on the requirements of your virtual machine. Let's say you need a virtual machine of, let's say 200, which maybe you're just going to assign 1 GB, and you have a computer which has 4 GB. That is okay, as long as you do not assign a virtual machine memory. Actually, we're going to come to this, so don't worry about that. We're going to come to that, and because now we are looking into virtualization, we need to understand how does it come to be, what should we put into consideration, and what should we do, okay? So it has, yes, it has, like I was saying, it has got all our physical resources of our server, and it has converted them into one logical, or it has converted them into different logical folders or files. And we said, remember the beginning, that these folders or files are divided into parts. We said we have a part of the configuration information, which has the information like the CPU, memory, hard disk, and all that. And then also it has where they store the user data that we talked about. Okay. So let's look also at the brief history of compute virtualization. How did compute virtualization come to be? And people think that it has just started now, but you can see as early as 1964, IBM had already started to explore how they can use virtualization on their mainframes. Yes? And then in 1972, IBM still same time launched virtual machines that were running on their mainframes. And then we go ahead and we see in 1999, VMware launched the x86 based virtualization products. They were using this kind of processors, and we see in 2000, and I'm perusing through this because I know what the course is focusing on and what is very examined. But if you want to understand more of the history of computer virtualization, you can go ahead and read on Google and get more material, or even dig deep in the material that I shared on Telegram for you to be able to understand. But for the purposes of our course, I will just be highlighting what I feel is important for you. And then in 2002, we are seeing here that Zen was officially open sourced. Okay? By open source, they mean that as long as you want, you can use it and modify it accordingly. You can access the system's, the program's source code, and you can use it based on what you want to achieve. And then CorumNet first announced KVM. And I also want you to take note of KVM because KVM plays an important part in this course. And we also have a chapter where we are going to be understanding and exploring the features of KVM and why KVM became so popular. So in 2007, HP went ahead and launched HPUX, Integrity Virtual Machines. And then from around 2006 to 2010, so many IT vendors, they came up with their own virtualization products because they realized that, you know what, we have seen what HP can do with virtualization. And IBM was busy enjoying, and VMware at that time, they were enjoying the features of virtualization, where you need to have two physical servers, which are very expensive. VMware would have its own one powerful physical server, and they could have so many machines that are able to do all the features of virtualization, which we are going to be looking at in the next few slides. Okay, so then we realized that from around that time to 2010, so many IT vendors, they came up with their own virtualization products. And we have also mentioned how around this time HP launched its HPUX, which they used. And also Linux Container was launched in 2008. And at the same time, Microsoft came up with its Hyper-V in Microsoft Windows Server 2008. But now Hyper-V is also available. It's a feature available in Windows. So you can even go ahead and activate it if you want to use Hyper-V as your hypervisor. We're going to come and understand what a hypervisor is in the next few slides. So Red Hat, by that time, Red Hat 6.0 started supporting KVM, and you see how KVM is becoming popular. Before this time, Red Hat was being built on Zen, but after or during in 2010, Red Hat decided to start supporting KVM as the only virtualization product. And we see in 2011, these guys came together and they said, you know what, why don't we come up with some kind of alliance so that all our products they can be compatible with what we have decided to use. So IBM, Red Hat, and HP plus Intel formed an open virtualization alliance to accelerate KVM. And you see how KVM is starting to be very popular. So in 2013, Docker was launched. We shall look at Docker in the cloud computing trends later on, and also Rocket was launched in 2014. So that is about the history of compute virtualization. And now we want to look at the important concepts of compute virtualization even before we decide to dig into compute virtualization. Like already we have been talking of the physical server, and usually the physical server we have been referring to it as the host machine. And this physical server can run multiple virtual machines like we illustrated in the previous slides, where we have different kinds of OSs and applications installed on those virtual machines, and we can also have other applications installed on our guest OS inside our virtual machines. So the core of virtualization technology is just between the host OS and guest OS, okay? Between this host OS and the guest OS. Because what does it, like virtualization is like puts another layer on top of the host machine to virtualize the hardware resources so that we can have our guest OS to be able to run and emulate those hardware resources so that we utilize them even better. So we see here, we have our physical server, okay? This is the architecture of a physical server, or even your computer, yes? This is your computer. You can just think of it as your computer. On your computer, you see that you have your hardware resources on it. You have your CPU, you have your memory, you have your RAM, you have your network interface cards, you have your storage on your computer, and on top of that, you go ahead and install your operating system. And then on top of your operating system, which you're calling the host OS, you go ahead and install your operations, but your applications. But we have said that in our traditional way, or in a host machine that is not virtualized, we cannot run multiple OSs at the same time. So therefore, if we just wanted to use an application, let's say you have an application that you want to use, for instance, if you are a video editor and there's an application like DaVinci Resolve which you want to use and it is only available on Mac OS, you find yourself that you may need to buy a Mac OS for you to be able to run such applications. Like let's say if you're a producer, there's a very common application called Logic Pro that so many producers are using, and it is only available on Mac OS. And let's say if also you're a producer, there's also another common easy to use application that so many Afrobeats producers are using, and it's called Fruity Loops, FL Studio. But FL Studio until of recent was only available on Windows. So if you had yourself a Mac PC or a Windows PC and you wanted to run Logic Pro, you would not be able to run that application. You would need to go and buy, I repeat, you need to go and buy a MacBook Pro or a Mac Air or any computer that has Mac OS installed on it for you to be able to use that. But remember now, it is just one application, meaning you're going to go and buy a MacBook Pro of 4.5 million, let's say if you're a producer. And all those resources, you find that your Microsoft Office and Microsoft Word and everything else, you're already using it on your Windows PC. So you find that you're going to have all those hardware resources available to you, and you're not going to be even using them. So you are underutilizing the hardware resources. So what virtualization does, it gives us the capability of you saying, you know what, let us just go ahead inside our virtual machine here and install Windows. If you are using, let's say, MacBook Pro or Mac OS, and install Windows, select the hard disk you created, go ahead and install Windows and go ahead and install your program. Do everything you want to do here without you. So I'm actually using these other idle resources or resources that were underutilized. and I'm now utilizing them to be able to achieve what I want to do. So we are seeing the architecture now of our virtual machine. We are seeing with our virtual machine, we have what we are calling the host OS. And the host OS, the host machine, so we are seeing we have our host OS, and we are seeing the host machine, which we are calling the physical machine or your computer or the server, has an operating system installed on it. Okay? So we have our operating system installed on it, and this is what we are calling the host OS. So we're seeing our operating system installed on it, and on top of our operating system, for us to be able to virtualize, we shall need a hypervisor. A hypervisor which will help us virtualize our hardware so that our guest machines are able to utilize the resources very well. So, and on top of that, we install our guest machines on our hypervisors, and also we install our guest OS on our guest machines. So that is our architecture of the concepts of compute virtualization. So we have talked about the hypervisor. Sometimes it's called the virtualization software layer, or sometimes it is also called the virtual machine monitor, the VMM, okay? And we come to realize that this guy here, we have two types of hypervisor, and I think we are going to be looking at that in the next slides. So I hope at this stage we are clear with this, and if there's anyone who has any question or concern before we move to the next stage, can ask me anything related to this particular slide.
Hello.
Yes,
Diana here.
Yes, Diana.
Is it okay if you can repeat which is installed where? I got to know that the host operating system is installed on the host machine. Okay, is it okay if you can run through the explanation of what is installed where?
Okay. We said on your physical computer, who was speaking before?
It's Dana.
Yes, Diana. So we said on your laptop, which resources do you have? What hardware resources
Windows.
do you have?
Pardon?
The hardware resources that your computer has.
CPU.
Uh-huh.
Monitor, CPU, mouse.
We are looking at compute.
Memory.
Under compute, we have the processor power, we have
CPU.
memory, and the network, isn't it?
Yes.
In your computer, when they asked you what were the components of a computer, do you remember that question?
Yes.
Yes, so we have our memory here. So these are the hardware resources. So you go ahead and install an operating system on your hardware resource, on top of your hardware resources, in the typical way, on your physical machine, which is not virtualized, isn't it? So you install, like, let's say, Microsoft Windows. Diana, are we together?
Yes, we are together.
Okay, so let's say we have Windows installed as our host OS. And on top of Windows, we are using PowerPoint. We install PowerPoint. On top of Windows, we install Zoom. On top of Windows, we install VLC. We install all other applications that we want to use. That is the physical machine. That is how we have it in the physical machine. So when it comes to a virtual machine, how do we come to a virtual machine? This is how we come to the virtual machine. We have our very same physical server, the one that you saw here, with our resources, okay? we have our same physical server here, isn't it? With our resources.
Mhm.
So what we will do, we will go ahead and install what we are calling a hypervisor or the virtual machine monitor. Okay? And we are going to look at, we have two types. We have type 1 and type 2. Where type 2 can be installed here after we have installed our operating system or our host operating system. And we are going to see that. Okay? So after installing, the reason why we are installing a hypervisor, because we want it to help us emulate our hardware resources that we have, that would have in our physical machine, your RAM, your memory. Like you saw, like you saw this is my hypervisor VMware. Are you seeing it? It's my hypervisor, which is going to help me manage the memory that I have for my different computers. And I can choose to increase the settings, I can choose to manipulate, I can choose and edit the settings of my virtual machine and change some few things on my virtual machine. Okay, so this is my hypervisor and I installed it on top of my operating system to help me emulate those different hardware resources so that we can utilize them. If I have my memory on my computer here and I am not using it, let's say I'm just using Zoom, and you see installed, because now they're running, but before you see I'm running two virtual machines, but I'm only now using, okay, I'm using 73% of the memory on my computer. Okay? And you see I'm using 36 or around 30 something, 40, 50 something of my CPU. So let's say if on normal days I am underutilizing these resources, they could do more and I have more things to use them for. I could go ahead and set and utilize them and emulate or provision them, like our colleague explained in our first or in our second lecture. So this is my hypervisor, or what we are calling the virtual machine monitor. Because I'm using it to monitor my virtual machines, or I'm using it to also at the same time emulate my hardware resources that are available on my computer. So I'll go ahead like I showed you. I went ahead and created a virtual machine on top of my, now this is my hypervisor. So on top of my hypervisor, I will go ahead and create a virtual machine. Okay, I'll go ahead and create a virtual machine. I have just created this virtual machine which I'm trying to install here, the Windows virtual machine. Which I'm trying to install here. Okay, I've just created it. After, now that is what we are calling the guest OS. Okay, which I'm installing on my guest machine, which I've created using my virtual machine monitor or my hypervisor, which is helping me to talk to my operating OS or to talk to my physical server. So like I said, I can go ahead and install, like I'm running, okay, my Ubuntu here. I can go ahead, you see this is Ubuntu. This is my guest machine of Ubuntu. So I can go ahead and let me punch in my password real fast. I can go ahead, I can go ahead and install other applications inside my virtual machine. Okay, like you see, I installed Firefox here and I have other applications installed inside my virtual machine. And this is what this slide is saying. And you see, even at the same time, we are able to run different because this is now an instance. We have a logical folder of these things. Okay, you see we are able to run, all these machines are powered on. The Windows machine is powered on, and also the Kali Linux machine is powered on, and also my Ubuntu Linux is powered on. Okay? And I'm able to use them all at the same time. Okay? And I can power them off and on using my hypervisor, just like you have seen. So I go ahead and I install my other applications on top of my guest OS, which we are calling the guest OS. Okay? So what we are trying to say here, or what I want you to take out of this, that we have our physical machine or our server, and on our server we have our operating system running in a physical machine, and the tool we use to virtualize the resources is called the hypervisor. Sometimes they call it the virtualization software layer, or sometimes they call it the virtual machine monitor. And what the guest machine are those machines running inside our hypervisor, or what sometimes we call the virtual machines, which are created through virtualization. And also the guest OS is the OS that is running inside our guest machine or our virtual machines. Diana, are we together?
Yes, we are together.
Okay. I see some few hands here. I'm going to take Yusuf and Edward, then we move to the next slide.
This is Yusuf.
Yes, Yusuf.
I just wanted to know, can this one affect the operating speed or the processor speed of the computer? Because when we looked at the storage, we can increase the storage speed, I mean the capacity of the storage, but how can we really do with the processor speed of the computer? Because that one we may not be able to increase it. Then too, can that thing, that virtualization machine can be really work offline? And is it really on market, like can go on Google and download it? Then 3, what is the standard processor speed can I install on my machine, like you're using that virtual machine? Thank you.
Okay, Yusuf, those are quite a number of questions. But yes, like you saw, and I want to highlight and mention now, virtualization does not improve the performance of your physical computer. I want you to understand that and take note of that. It does not improve the performance of your physical computer. What it does, that it helps you better utilize resource utilization. Resource what?
Utilization.
Yes.
Ssendi. My question on that is, like my computer, it has a low processor speed. Then I want to load on another virtualization machine. Can it really accommodate it?
If your computer has low specifications, then even why are you trying to virtualize it? Because you are not going to utilize anything. Okay?
Okay.
Yes. So as you're going to see in the next slides, there are some things you must put under consideration, like some things like memory overcommitment. If your computer has 2 cores or CPUs, how many of them can you actually allocate to your virtual machine? So where virtualization comes in case you have resources and you're underutilizing them, there's a better way you can utilize them and have your physical server. And usually that's why they're using a server, because a server is a powerful machine, isn't it?
Yes.
And instead of you running one application on a server, and because you have installed Windows, and the other application, your mail server, has to run on a Linux server, and you have to buy another server, that does not make sense. And yet you still have over 80% of RAM unused. Where would you go ahead and spend all that money and yet you could just virtualize this physical server so that you have your guest OSs here. You have one which is having Linux, and you also have, you create another virtual machine here, and you also have another guest OS which has Windows, and you go ahead and install those applications. And you can even have more depending on your need, as long as the resources are available to you, like you're going to see. Okay?
Okay.
What was the other question before I take Rajab and Osbat?
I was asking for the standard process speed, which I can really upload on my machine.
We just work with what is the recommended provisioning we should use. Yes?
Okay.
So we are going to look
Okay.
at that when we are,
Okay.
yes, dealing with computer virtualization. Okay?
Okay, fine.
Don't worry
Okay,
about
fine.
that.
Thank
You'll
you.
be able to see. And these resources are available. VirtualBox is open source. You can download it for free from the internet and you use it to create your own. And actually, as even you're downloading it, it has what they are calling software requirements. You'll be able to see if your computer supports it or not. Okay? Yes, Osbat, then I take Rajab.
Oh,
And lastly, Edward, then we continue
fine.
to the other slide.
Yes, thank you. I want to know, can you install a guest operating system that's different from a host operating system? And another thing, can you install an application that can run on a
That can run on what? I can't hear you. You broke. You're breaking.
operating system. I mean, can run on a operating system and it cannot run on the host operating system.
Okay. Let me ask you just a moment. Which operating system do you see here that I'm using?
Windows 10.
Windows 10, yes. In my virtual machine here, okay?
Yes.
You have realized I installed. Let me first, some people are writing on my screen. So let me first disable them from writing on the screen. Okay. Which operating system are you seeing here? Osbat? Ubuntu, which is built on Linux.
Yes, it is Ubuntu.
Yes. That answers your question, that I've been able to install another operating system in my virtual machine, which is not the same as my host operating system, isn't it? And as you look at the advantages, yes, of virtualization, this virtual machine is purely independent of my host machine. Even when I get viruses here or a program breaks down, it is not going to affect my other virtual machines or my host operating system. Okay? So I can install any application as long as Ubuntu supports you. Like this is like any other computer of Ubuntu. So as long as Ubuntu permits you to install that application, you can go ahead and install that application and it will work. Okay? So just think of this as you have created another computer on your computer, which is purely independent in the way it's going to execute and do its work. Okay? All right, so let me take Rajab. Rajab's hand is down. So I think
an application run on both operating systems.
What do you mean run on both operating systems? Kindly explain your question.
I mean, can take for instance the let's say a music player, application. Can you install it on you have Linux, Ubuntu, and Windows? Can you install it on both operating systems and it works?
And it works. If I can go ahead and I install Chrome in my Ubuntu operating system, and I'll be able to use it very well. And I'm also using my Chrome here. And it, like I said, this is purely independent of its host operating system.
I get.
You get? So whatever you do here does not concern the the host operating system. Whether you have an application which is as the same as that one, and those are some of the advantages of virtualizing, because it will save you from having those kinds of things.
Thank you.
Where you have conflicting processes if you're running the same applications on the same server. Okay, so let me take Edward, then we go to the other slide.
Hey, this is Edward. So my question is, the managerial platform you're using, were you using VirtualBox or were you using Fusion Sphere? Then the second question is, what's the maximum number of virtual machines that you can set up on the hypervisor that you're using right now?
Okay, I was using, just a moment. You said I was using, what was your question?
My question is, the platform you're using to control your virtual machines, were you using VirtualBox or Fusion Sphere?
I was actually.
That's the first.
Okay, and then the next one.
The next question is, of the hypervisor you're using right now, what's the maximum virtual machines that you can put there?
Okay, as you are seeing, I am using VMware Workstation from VMware. Okay, this is VMware Workstation, but it is the same procedure as I would use my Oracle Virtual Box. Are you seeing it here? The Oracle Virtual Machine Virtual Box. It's the same. I could go ahead. I could go ahead and install and emulate as many things as I want in my Oracle Virtual Box. Just a matter of going on new and I create the virtual box that I want to create in my virtual box, okay? So it is just a different platform, but giving you the same thing. This is also a hypervisor from Oracle called the VirtualBox. The other one is called the VMware Workstation from VMware. And also when we go to our labs, you also get to use Fusion Compute, which is a hypervisor for Huawei. Okay. And then also you can go ahead, as long as you have the resources and the resources permit you on your physical server, you can go ahead and create as many of them. Okay? You go ahead and create, as long as you have the resources available, you just go ahead and create them. Okay? So you can create as many virtual machines as long as your physical server can support the provisioning of the hardware resources that you have available in your computer.
Okay, thank you very much.
All right.
Mic check.
We are taking Rajab, then we move to the next slide, please.
Mic check.
Yes, Brian. Okay, Brian, then Rajab, then we move to the next slide, please.
Oh, okay. So I wanted you to talk about the capability of sharing, like maybe some files if they're on the host operating system with the guest operating system. Hello?
Yes, please come again. I lost you a bit.
Oh, I said I want you to talk about the capability of sharing files between the two operating systems,
the host and the guest. If I want to share, maybe I have something on my host operating system, and I'd like to get it for using the guest.
Okay.
Yes.
Yes, Rajab. Rajab,
Have you
please
got my
come
question?
in.
Yes, good evening.
Good evening.
Yes, my question is, yesterday you talked about DNS history, IP addresses to like attaching like words to reference, let's say websites or machines you want to access. When using this
Rajab, you're breaking. I can hardly hear you.
virtualization,
Rajab, you're breaking. I can hardly hear you.
like softwares, does like
Okay.
do
I'll
those
take that question
two
after because
machines
you're breaking. I can hardly hear you. So Rajab, I'll take that question after.
Yes, so but my question is, does the pin and the version pin and the
Does the what? Okay, let's move to the next slide. There is a way which how you can trick your Brian. There's a way how you can trick your virtual machine so that you're able to share the files. And even if, for example, if your virtual machines are connected to the same storage access area, then you are able, or if you configured your storage of virtual machine to be able to access those other hard drives as external storage devices, then you are able to access or share files in between or across your guests, your virtual machine and your host OS. And then also you can also have access to some things like copying from the virtual machine and pasting from the host OS, not the files, but the text and the things that can be copied on the clipboard.
Okay.
All right.
Thank you.
You're welcome. So let's move to the next slide. Here on this slide, we are seeing that, sorry, just a moment. Okay, I want us to take the attendance at exactly 7. For those that were not on the call before, I highlighted some of the few important things. Today, we wanted to make sure that every one of you gets your data on time so that data can help you or support you to attend this class. But in that meeting, the administrators were wondering that this class is really huge, and they are seeing that according to the attendance list, that we have over 171 people registered, but here in the class, we are always having about 130, 120, 115, depending on the interval. And then they also wanted to confirm and find out from you how many of you are actually willing to go ahead and certify. It doesn't matter the number, even if you are 200, Huawei will go ahead and buy vouchers for you. But for planning purposes, we don't want to plan for 120 people, and yet you may be here and you're not planning to go ahead and take the exam. So if you're planning to certify, in today's registration form, there is going to be a field that asking you, will you sit for the final exam, or are you willing to do the final exam? For us to determine how many people we should plan for in terms of the exam, kindly either if you want to do the exam, fill in yes. If you don't want, fill in no, so that we know how many vouchers we are going to spend on, or how many vouchers we are going to buy for this class. And then also we realize in the list, as people are filling in their names, you always, I don't know, for some reason, I don't know why, you know your number, and you don't cross-check to see if it's correct, and you always fill in a wrong number. There are quite a number of inputs or data that is collected on the forms, and they are showing that the number is either incomplete or it is wrong. So kindly, before you submit the form, just cross-check and see, is this number the number? Is it my number? The digits all spelled out, and also your name, and also verify your email, because we have seen emails bouncing again and over again. So just kindly cross-check your details, because we're not going to ask you again, and I'm also not going to entertain again those people who come and say, I didn't spell my number correctly, I missed a digit, because you're now delaying the entire process. But I want to see to it and make sure that by tomorrow you get your data, and I'm going to push with the service provider and Huawei to make sure that at least by tomorrow, so by the time you come to the class, you are enabled to access the material and the training on time without having to spend that data by yourselves. So those are some of the things we talked about in the beginning. So if you're willing to take on the exam, kindly, you will fill in that form, yes. And also, if you have your Huawei user ID, if you don't have it, it's okay, the field will be there. I'm going to make it optional. So if you don't have for now, you can skip it. If you have, go ahead and put it there, okay? So yes, Alan?
Yes, just to be clear, since the numbers are put in an automated system, do you have to use a code, or you don't have to, like +256 something like that?
It's better you just start with 0, but it's okay. But you just start with 0, but it's okay to go ahead and say +256. It's all the same. The system can recognize that. Or even if you're coming from Kenya, +254, depending on where you're coming from, it's entirely okay. But now actually, I recommend that you this is how I'm going to know the people who have been in this class and who have been listening to me. You should all make sure your numbers start with +256. Okay, as you're putting them there, as you're cross-check, make sure that your number is +256. And we shall filter out all those that do not have they have your postal code starting with a number. If you are from Kenya or Rwanda, I apologize. If you're from Kenya, make sure it's +254, your country code. If you're from Uganda, you say +256. Okay, this is how I'm going to be able to determine those people that have not been part of the class. I know they'll get their form and fill it in. If you are here, kindly make sure you add that prefix before your number. Otherwise, if you don't, we're going to just filter them out. I hope I'm clear on that.
Are we supposed to do it?
I didn't get your question, you are breaking. Okay. I hope I'm clear. Just start with +254 or +256, depending on your country. If you are from Uganda, +256, then like 701 45 36 39. Okay. So okay, so let's come to this slide now. We have been looking at our hypervisor. Who can remember and tell us what the hypervisor does? What have we said about the hypervisor? Okay, Taki,
Excuse me,
Stephanie, you can.
Excuse me, Samuel.
Let me first hear from Stephanie.
Hello, good evening.
Good evening.
The hypervisor it's a tool that we use to virtualize and also help the guest machine and the guest OS operate with the hardware.
Okay.
Is that correct?
Yes, it's correct. Thank you. So here we're going to, someone was saying something. Someone was saying something.
The hypervisor virtualizes the hardware for the guest machine to be able to utilize the resources.
Yeah, thank you for that. You're correct. So here we are looking at the hypervisor, and we are saying we have two types of hypervisor. We have type 1 hypervisor, and the type 1 hypervisor is a dedicated kind of hypervisor which is dedicated to converting the host resources into virtual resources for the guest OSs. Okay, so in actual sense, the guest OS runs as a process on the guest, on the host, sorry. So therefore, these kinds of type 1 hypervisors are also called bare metal because they are installed directly on your host machine or your physical server. Okay, so we have our host machine here, and we are saying with type 1, take note of that, the hypervisor is the one which is acting as the operating system. Okay, we have our hardware resources, the CPU, the RAM, and then on top of that, you just install the hypervisor or the virtual machine monitor. And then from it, where you can just choose to create the different virtual machines. And then you choose to install the different guest OSs if you want, and then your other applications on top of your guest OSs. Okay, so this is type 1 hypervisor. And we see we have examples of type 1 hypervisors, the hypervisors that are directly installed, on our hardware resources. Some of them we have Zen. We saw Zen in our history, okay? And the others we have the ESXi, okay? And then also we have the Fusion Sphere or Fusion Compute by Huawei, okay? And then this brings us to the hosted virtualization, which you're also calling type 2. Just like you hear the word hosted, someone is hosting this hypervisor. Okay, someone is hosting this hypervisor. We are saying that we have the hardware. Then on hardware, we have our operating system, like I showed you, the Microsoft Windows. Okay, and then on top of our Windows, you have our other applications installed, Microsoft Office, Chrome, Zoom, and other applications installed on our operating system. Just like you saw my operating system, I have all these other applications installed on them. Okay, and then on top of, alongside my host operating system here, alongside my host operating system, on top of it, I'll install the virtual machine monitor, which I'm calling the hypervisor. Okay, the hypervisor. Then on my hypervisor, like you saw, that's where I'll go ahead and I'll install my I'll create my virtual machines and then install my guest OS and then have other applications run on my guest OS. Okay, so you have already seen, before I give you some of the examples of this type 2 virtualization, you have already seen some of them. So let me ask, can I hear just people mention some of them that you have seen that I've been using, because I already have a host OS, which is Windows, which is installed on my computer. Then I went ahead and I have showed you at least 2 of them that I've installed on my host OS. So can I hear you mention some of those examples before we move forward? Yeah, thank you, Helen. Thank you, Henrietta. Those ones that you are mentioning, the Kali Linux, the Ubuntu,
VMware.
Yes, the ones you have been mentioning, the VMware Oracle VirtualBox. Okay, all right. Okay, that is enough. So I heard people mentioning Linux and
Hyper-V.
Okay. that is enough.
VirtualBox.
All right, thank you. That is enough. So I said
VMware.
okay. So we have VMware, like you're saying. We have Hyper-V. We have Hyper-V. We have one from Microsoft. This one is VMware. We have the Oracle virtual machine like Oracle. And these are all installed on top. And here we also have Fusion.
Ssendi, I'm sorry to interrupt you, but we can't hear anything.
Someone is having two devices and getting an echo.
You have background feedback.
Okay, I've muted you. Sorry about that. So I had people mentioning Linux, and they're mentioning Linux and they're mentioning Ubuntu. These are now the guest OSs that you saw that I installed in my virtual machine, which I created, that are running inside my VMware, this one, or the Oracle VirtualBox that are running inside my Windows 10, that are running on top of my computer. Okay, and that is what we are calling, the type 2 virtualization. And also what you should take note of type 2 virtualization is that all the hardware resources are managed by the host OS. Okay, the physical resources that are available on my machine are managed by the host OS, and the virtual machine monitor goes through the host OS to be able to communicate with the hardware resources that are available on my physical machine. So that means our virtual machine monitor or the hypervisor will obtain the resources, the memory, the CPU, by calling the host OS services to help it virtualize those hardware resources of the CPUs, the memory, and also, of course, the input and output devices that are connected to the computer. Okay? So what happens is this virtual machine is created. After it is created successfully, it creates a process, or it schedules a process to the host OS, and the host OS will see it as a process to help it virtualize those resources that we have talked about. Okay, so we have already mentioned some of the examples of type 2, but some of the advantages of type 2, it is that it is easy to implement, it is easy to use. Okay, it is easy to implement. If you wanted to use it today, you just go on the browser, search for it and download it, and you are able to use it on your computer. Okay, the disadvantage it has is that it is only supported by the operating system that supports that application. If Mac OS or if Linux, I'm just saying, does not support Oracle, or for example, if you wanted to install Fusion Compute is the Hyper-V for Huawei, but it is only supported by Linux. Okay, so if I wanted to install it directly on my machine, I will not be able to on my Windows. It means I will need to first install Linux on my machine, then I am able to install the Fusion Compute on top of that Linux for me to be able to use. So that is one of its disadvantage. Okay, and of course, like some of the colleagues have been mentioning, they're being concerned. Now, what is the performance going to be like? Of course, the performance overheads are there because remember also the host OS needs to run its services. So this virtual machine monitor is also competing with the host OS for those resources, not necessarily computing, but remember they both need to use the resources. So that's why sometimes there is performance overhead. And that's what takes us to our type 1 hypervisors, or what we are calling the bare metal. We are calling the bare metal because it is just installed on the bare metal or the hardware of your physical computer. Okay, so here the virtual machines can actually go ahead and run the applications that are independent of the host OSs. But the disadvantage with this is that if you're going to implement it, some of them, because they're even terminal, they don't have graphical, they don't have GUIs, user interfaces. So sometimes it is a bit hard to use, but also it is hard to develop, since all those kernels are developed basing on the solution that you want to deploy. Okay, so I think let's see what's in the next slide. Let's also look at before, this is going to be the next slide, the last slide before it's almost coming to 7, before we pass out the registration link. But okay, so we are looking at some of the advantages of virtualization. Okay, we have been looking at the advantages of virtualization, and I also want you to take note that both type 1 and type 2 have the same advantages of virtualization. Briefly or quickly speaking, what is the other name for type 1 hypervisors?
Bare metal.
Bare metal virtualization.
Bare metal.
Okay, that is good. Then
Bare metal.
All right, that is okay. That is okay. So what is also the other name for type 2 virtualization?
Hosted.
Hosted.
All right, that's enough. That's enough. Let me meet you. Okay. So I see people are in class. Okay. So here we have one of the advantage of virtualization, and we are seeing it is partitioning. Okay, we already saw how we are able to have those logical files independently to help us create different virtual machines on that computer. And we have the capability of allocating the different server resources to multiple virtual machines. Just like the way you saw, I had my virtual machines here in my VMware, and I was allocating different memory and storage. Okay, so I'm partitioning, I'm actually, in actual sense, I am getting my storage that I have and I'm partitioning it. Like you hear the word partitioning, I'm getting my processors and I'm partitioning them to different, I'm partitioning them for use to different virtual machines. Okay, so this helps that each virtual machine can run independent operating systems. Okay, and that means that even each OS can have its independent, like, kind of virtual hardware, because if I've configured it, this guy will get its own IP address, and if it is using its either network translation or bridged mode, where it is going to directly use the host network interface card. We shall look at that in the network basics for cloud computing. But already we have partitioned our hardware resources available to use for our to virtualization. Okay, so we're able to partition, and we say, you know what, this virtual machine, you should use 1 core of my CPU. I have 6 cores, so these 2 cores are going to be used by that one, and then this one will use 1 core of my CPU, and I'm going to allocate 2 GBs here. I have 16. I'm going to allocate 2 GBs here, and I'm also going to allocate 1 GB here. I'm also going to allocate 1 GB to this virtual machine. So I'm already partitioning my total 16 GB, and because I'm not fully utilizing these resources, so I'm creating more machines that are going to be running other things that I need to do, but while partitioning these resources that I have that are available on my on my physical machine. So resource quotas are allocated to each partition to prevent resource overuse or overuse by virtualization. So who was asking if I have my computer and it is, we are going to come to that segment and we are going to see resource quotas. So, but here we are saying we have resource quotas where we should know that if we have this amount of memory, we should not exceed 150% of what and why. We are going to come to that in the next coming slides. So don't worry. Okay. So, and also one thing to note, each quota is allocated for each partition to prevent resource overhead. And also you should note that these different virtual machines, they are all independent of the host OS. Okay. So they will do whatever they have to do because they are partitioned. Okay. They are partitioned and they are there, and that's why all these characteristics are somehow related, and that's where, because they are partitioned and because all of them are using the resources in a partitioned kind of way, then it helps them to be isolated from each other. So in that, even if my Ubuntu operating system fails here and it crashes, it will not stop my Kali Linux operating system to work. I'll go ahead and use it very well. Even if I shut it down my Kali Linux virtual machine abruptly, I'll go ahead and use my Windows 10 update virtual machine and I use it without a fault. Okay. Even if I was, let's say someone attacked my computer, I downloaded a file which has viruses, these other guys are going to be protected because they are the advantage or characteristic of virtualization. Because it is isolating each virtual machine and it is independent of the host OS. So even if this guy has viruses here, the guest OS inside here will be protected. Okay, so in the traditional way, if you have your physical computer, your host computer, and one application lags and crashes, your computer, you may have to restart it. But here, if one and you have other operating systems running, even your host OS, you will not be affected. This guy will just go off. You just go in your configuration settings, try to figure out what went wrong. Did I configure something wrongly? And then you power it on. Again, you start the guest, and then you're good to go. So we are saying here that isolating, we mean that multiple, these guys you're seeing here, these multiple virtual machines, since they are created in a partition and they are logically isolated from each other. Okay, the isolation feature solves the problem of crashes like you're seeing here, or like I said, if the application breaks down or if there's a driver failure and you have to restart a few services. If other operating systems or other virtual machines are on the same server, they will continue running. Your users will be able to still access services from these other guest OSs, and that is a characteristic of virtualization that we need. So that's why we are saying that these guys are isolated from each other, and that's what also means that they are independent of the hardware resources of that physical computer. So this means, maybe before I speak about this, let me also come to here and say, the way the files are said. Remember, before we said these guys are encapsulated. Remember, we said actually we didn't say they're encapsulated, but we said they are converted into a logical file, isn't it? As you see this animation here, how this guy comes and is converted into a logical file, which logical file we said has both the configuration files and the user data files. So they are encapsulated, and even when I go in my directory where I store my virtual machines, where they are stored on my physical server, here, you'll see They are just folders here. I have a folder for Kali Linux, Ubuntu. Maybe let me try to highlight Kali Linux, Ubuntu, and Windows. So if I'm to go ahead and I open inside Kali Linux, I'll just see some files with an extension of VMDK. I'll just see some extension of I don't understand. So this is encapsulating so that they're getting all the files. But remember, we opened Ubuntu and we saw Ubuntu. There was files that are installed. We saw Firefox. We saw other files that were on my desktop in Ubuntu. But here they are encrypted and you just see their files. And if I wanted to transfer this Ubuntu to another computer, all I need to do is just copy this, okay? All I need to do is just copy that, go where I want to put it, paste it, open my virtual machine hypervisor as long as it supports, and I repeat and I emphasize, as long as it supports that file extension, I will be able to open it. I just go and open, and then I open that virtual machine. Maybe let me try to open my Kali Linux, or let me first shut this down. And I try to open my, using, I've never also tried it out, but let me try and use Oracle Outbox to actually open a virtual machine, of that was created by VMware, let's say Kali Linux. I think it doesn't support the file format. Okay, it's something that I'll explore and I'll see if we are able to open and launch a virtual machine from other platforms. Okay, so I was saying they're independent. So if I wanted to migrate these ones and I move them to another computer, I'll just carry those files that I've showed you and I move them and I copy and paste them on another computer and I am able to use it. So this does not affect the physical machine. Like if I wanted to transfer my operating system on my physical computer, the host operating system, I'll need to remove my hard drive. Or I'll have to go an extra mile and clone it. And even the cloning technology has just come up of recent, and of which it is also not 100% safe. But because it is encapsulated in those files and those file formats, like I said, it also saves them from being infected with the viruses that were the viruses, or if anything is has affected the physical or the host machine. So that's why we are saying that the isolation feature allows you to control resources to implement performance isolation. This, you can specify the minimum resource usage of for multiple workloads. Application or OS can run a single machine without causing problems such as application conflicts and DDL conflicts mentioned in our discussion about the limitation of traditional 32-bit architecture. Okay, we are also seeing here, I see like my mic is off. Can you hear me?
Yes.
Okay.
We are able to hear you.
Yes.
All right.
Okay.
Thank you.
A bit low.
How about now? Am I low?
It's okay. Yeah.
No,
you're okay.
it's fine.
It's fine.
The audio is clear.
The audio is clear.
Yeah.
So I was saying previously that each of those files that I showed you, let me go back to those files. They are
Yes, we can.
Are saying that each of these files that I was showing you, where's my virtual machine? Okay.
Yeah.
I'm saying that each of these files that I was showing you here, they are saved in a group of hardware independent files. So it doesn't matter, I just copy these files, go on a file, because they include the hardware configuration, and I want you to take note, they include the hardware configuration, they include the BIOS configuration, memory status, disk status, and CPU status. So you can actually just copy and save and move your virtual machines. I'm seeing, yes, Wilbur?
Yeah. So,
Yes, Wilbur.
so my question is in case like in the case I override the existing operating system, which is acting as a host operating system.
I can't hear you very well.
He's saying, what if he overloads the current operating system?
And you have bottlenecks. You have bottlenecks and you have performance issues. Your computer will freeze and crash. It's like saying, what if I run so many applications that are going to overconsume my resources that I provisioned on my computer? We are going to look at those quotas and what would be the risk of you overcommitting as resources that are not available. And in fact, in some hypervisors, they will not allow you because they will tell you this is what we recommend. This is the maximum you can go, and please do not go beyond red. Okay? Like you saw here when I was creating my virtual machine here. And I went, let's say, let me just come, which one is off? Linux is off. So if I come here and I'm editing my resources, you see, they are telling me that the guest OS recommended minimum is 1 GB. And they're telling me that I cannot go beyond 13, okay? So, and the maximum recommended memory, like this is the maximum recommended memory for this guest operating system. And with Oracle, it does it very well. It even puts it in red, the Oracle VirtualBox. Okay? So I was saying here that because these guys, so it does not affect, you can actually just copy the set of these files and you go and paste them on another computer. As long as it has VMware, you are able to load them there and you're able to run the workstation and you're able to run the virtual machine with all the configurations and the files as I've been working on before on my computer, which would be a very difficult case if I wanted to migrate this operating system here on my computer to a new physical server without me necessarily having to remove the hardware resources. Okay, so meaning that's why we are saying that and even if when you move it, it will not be very compatible because the drivers that were installed on your operating system are drivers for this particular hardware. Okay, so but with encapsulation, they are hardware independent. Okay, and I want you to take note of that. With encapsulation, they are hardware independent. And that's what takes us to this advantage of also independent. Like I've said it, and I won't spend a lot of time on it. Because after they are all put in that folder that you saw here, let me clear my screen. After they are put in that folder that you saw here, after they are put in that folder, you saw there, they are not dependent on that host's physical or server or physical machine hardware resources. They don't even need to know the underlying hardware resources that are on that machine. So you can just migrate the virtual machine by just copying the device files, the configuration files, and then you're good to go. You go, paste it on another host, and it is running as long as you have the same hypervisor or a hypervisor that supports those file extension from that given virtual machine. Okay, so which makes it easier, and you'll see how we are going to be applying all these things. Because with virtualization, actually, when we go ahead, you'll see there's something that they call high availability, where our virtual machines can even be able to migrate from one physical server automatically to another, depending if there's a fault somewhere, or we shall look into that. But because it is hardware independent, all that is being able, or we are able to achieve that because of such features of virtualization. So in brief, we said we have partition, And we also said we have, they are isolated from each other, and the faults, the viruses cannot affect either, even the operating system. We said the files are encapsulated into those files that we said. And then also it is hardware independent, okay? So unless I'm going to take a few questions, then we do our registration, then we shall come back to CPU virtualization. Okay, so I'm seeing some hands up here. Yes, I'm going to take Pius.
Yeah, my check.
Alan, then Serugo, then Rajab. Yes, yes, Pius.
I just wanted to make a submission on top of your presentation.
Yes, yes, please.
It is true that VirtualBox and VMware files are compatible. Yes, at some point you will get a warning message, but eventually when you power the machine, it works fine, because I've tried it so many times in the data centers. So they are cross-platform compatible.
All right, thank you for that observation. Yes, Alan?
Yes. I think I'm going to take us back, but I get isolated. They are like independent of each other. What happens in the other one doesn't affect what is in the other one. Independent, they are independent of the hardware, so they can be moved from one physical machine, host machine, to another. But what I can explain is encapsulated. How do you explain that?
You see, with encapsulation, it is you being able to hide some information, some level of abstract level, isn't it? So with encapsulation here, as you see my files here, they are encapsulated into these logical files that contain my configuration files and user data. Even by you looking at them or opening them, you won't even see the files I have in my Ubuntu folder, isn't it? So this is the encapsulation they are saying, that your hypervisor or virtualization is going to get your virtual machine or the virtual machine files and the guest operating system, and it is going to encapsulate them. Because for them to be isolated from each other, like I've explained, they need to have some kind of confinement. They need to have some kind of data, some kind of data format that they are encapsulated into, that only the hypervisor will understand. Okay? And that's why the viruses, for it to help it to be able to be isolated from each other, that's why the viruses cannot penetrate, because you see they're on the same physical file, but even you see these files are not usable by the operating system, apart from the logs, which are meant for me to know what has happened on my server, on that virtual machine. But if I try to open these guys here, Windows will not understand, and it will tell me, boss, what are you trying to open? What application should I open this file with? Because it doesn't even understand. So there's that kind of abstraction. There's that kind of hiding the information underlying within this virtual machine. And that's why we are saying that each virtual machine is served as a group of hardware independent files to support your independent argument, and including hardware configurations. So all the configurations are there and they are saved. And that will also help us to migrate or copy and move these files from one physical host to another. Okay? Hello?
Yes, I think I get it.
You get it, okay. And that's why you should take note. For us to be able to isolate, we need to first encapsulate. We need to have some level of abstraction. We need to hide something, okay? And for us to be able also to move them, because for us to make them independent from each other, we need to encapsulate them into into those logical trees we talked about. And that's why we are saying that encapsulation actually is the most important characteristic of virtualization. Okay. So let me go back to my slides. I saw someone's hand was up. Yes, Serubu or Helena, whoever can speak first.
Yeah, it's a problem. So I'm asking, like you talked about examples of guest operating systems. You talked about Ubuntu and then Kali Linux, but then can I also install Mac OS as a guest operating system, for example?
Yes, you can install any operating system as long as you have the installation media. As long as you have the bootable file for Macintosh, you can go ahead and install it there.
Oh, all right. Thank you.
Yes, Rajab.
Yes, yes, Samuel. Can you hear me now?
Yes, I can hear you.